Hello students, welcome to EPG Pathshala. Myself Yatrik Patel and I am working as scientist in Information and Library Network Center. In the paper Digital Library, today we are going to learn about the digital library architecture. You all know that this digital library is always built around the prevailing internet technology as well as web technologies, and to make it more interoperable we have to follow the standards and protocol which are the driving forces behind internet technologies as well as web technologies. Moreover, in this module we are going to learn about the important aspects of digital library, that is its modularity, its granularity, its scalability, its redundancy, its accessibility, its distributed processing as well as its robustness. Moreover, we are also going to learn about the client server architecture which is behind this digital library. We all know that this digital library is not a package. You have to build it from bits and pieces, bring it together, and to work this thing in harmony, we need to have standards and protocols which needs to be adhered to. So, in this module, we will be learning about the client server architecture, the important standards and protocol to meet the characteristic of digital library as well as several other aspects. Let us have an overview of digital library architecture. See, the internet and web technologies are principal mechanisms that are deployed in digital library to search, navigate and deliver electronic resources to the globe. The digital contents in digital library can be available on a single location or it may be distributed across the network, and the digital library implementation follow the client server architecture as does the web and internet technology. The online information services like Dialog, BRS Search and STN worked on host terminal technology, wherein hosts were huge mainframe computers that controlled all the aspects of search and communication sessions, and dumb terminal were connected to the host computer. In this architecture, a centralized server managed communication, user query interaction, database management and data presentation. The data from different sources had to be converted into a single homogeneous structure and organization. In contrast, enabling technology behind digital libraries provide for seamless access to heterogeneous digital objects created on different platforms and hosted in diverse environment distributed at different locations on the internet. Now let us see client server architecture. In client server architecture, client and server refers to both computer program as well as to the physical computers. The client program typically resides on user's personal computer, while the server program resides on a server that hosts information contents. The server program and client program communicate over a telecommunication network using a well-defined protocol. The client program or say web browser is responsible for making a request to the server and for displaying the information it retrieves from the server. The server is responsible for receiving requests from the client, controlling access to the information, performing computation which is needed to retrieve the information, sending requested information to the client after authentication of the client, as well as handling the database management task and processing requests from the client. In client server architecture, middleware are the computer programs that connects software component or applications on the client as well as servers. Middleware normally resides on both client as well as server and ensures that the client and server can communicate with each other irrespective of different hardware and software involved. This is being made possible by using standardized sequence of messages called protocols. The application programming interface, the API, is the middleware component that facilitates the transferring of messages between clients and server based on decided protocol. The API protocol defines a set of messages that both the client and server understand. The client's API translates the message into a form that is platform independent and transmit it to the server over the network. The server's API receives the messages and translate into form that a server can understand. The server receives the messages and responds to the client through its API. Middlewares are used most often to support complex distributed application. It includes web server, application server, content management systems and similar tools that support application development and delivery. Now let's have a look at key principles of digital library architecture. As we all know, the major challenge in digital library design are caused by differences in computer systems, file structures, formats, information organization and different information retrieval requirements of collection such as e-journals, e-book, reference sources, online courseware, GIS and whatnot. And this all should be accessible through digital library. While the web has emerged as a preferred media, the use of standards and protocol makes it possible to make digital collection interoperable and accessible seamlessly. Some of the important features that should be considered while designing a digital library architecture are as follows. The first one is open architecture. Open architecture refers to computer architecture or software architecture that allows adding, upgrading and swapping components or software modules. Open architecture allows potential users to see inside all the parts of the architecture without any proprietary constraints. Digital library design should use open architecture and a set of well-defined standards and protocol so as to facilitate scalability and interoperability. Scalability, extensibility and sustainability. These three are most important design feature of digital library. The digital library design should ensure that the software should be able to handle large quantity of data and hardware and network should be scalable to handle large quantity of digital objects and its transmission over the network. Digital library design and planning should provide for human and financial resources required for sustaining the digital library on long-term basis. Seamless access. The digital library should provide transparent, seamless and platform-independent access to distributed array of information resources to the user. Interoperability. This addresses the issue of ability of digital libraries and its component to work together effectively in order to exchange information in a useful and meaningful manner. Use of open architecture and a set of well-defined standards and protocol ensures interoperability amongst heterogeneous digital libraries in distributed environment. Federation. Distribution of responsibilities for content creation, management and administration of various functions and services of digital library. it needs to be ensured that the participants follow the agreed standards, technologies and tools. Digital preservation. The architecture of digital library must ensure consistent and long-term access to its collection. Modularity. It is a design approach that adheres to four fundamental tenets of cohesiveness, encapsulation, self-containment and high binding to design a system component as an independently operable unit. Platform independence. The digital library architecture should be platform independent both at hardware as well as software level. Multiplicity of files and formats. Digital library should be able to handle multiple files and format such as structured or unstructured text, audio, video, images, graphics, animation, etc. Location independent identifiers. The digital objects in digital library should support location independent identifiers such as handles, PURLs, DOI and open URL. Now look at the interaction between key components of digital library architecture and design. As shown in this schematic on the screen, the user connects to digital library via user interface. The first thing it encounters is indexing service, and these indexes are being obtained from various collection services which are part of repository service, or say repository service contains various collection definition, and all these four components, that is collection service, indexing service and repository service, are interconnected via a naming service. Now if we see the user interface, it facilitates to explore its collection, it provides interface to conduct searches, it navigates through hierarchical menus of subjects, and it selects and deselects searchable options and sort search results. The principal role of repository service is to store and manage the digital objects and its metadata. The metadata that describes the digital objects to facilitate searching and discovery may be extracted automatically or can be created manually. A large digital library may have several distributed repositories spanned across various geographical locations depending on collection it holds. The digital library developers interface with digital library using repository access protocol, which is known as RAP. This RAP recognizes rights and permissions to enforce intellectual property rights. The naming service is basically provides location independent unique identifiers. These identifiers must remain valid whenever the documents are moved from one location to another location. A number of registry or resolver based applications are being used currently for providing persistent URLs to digital objects. These unique identification schemes do not directly describe the location of resources to be retrieved, but instead directs a user to an intermediate registry or resolver server that maps the static persistent identifier to the current location of the object. The examples of most used registry or resolver based applications are PURL, handles, DOI and open URL. The process of indexing digital object involves linking of databases of digital objects to a text database consisting of keywords and subject descriptors. Digital objects are required to be linked to the associated keywords and subject descriptors to facilitate their retrieval. It is assumed that a digital repository has several indices and catalogs that can be searched to discover information for subsequent retrieval from repository. The search system and content delivery consist of the design of digital library system should support searching of its collection. The search engine should support features like Boolean searching, proximity searching, phrase searching, etc. Most digital library software integrate external search engines. Now let's see various digital library models and architectures. While different digital libraries have their own underlying design and architecture, most of them support key components mentioned above. While different digital library have their own underlying design and architecture, most of them support key components as described earlier. Some of the important digital library architectures are as follows. The first one is Kahn-Wilensky architecture. Kahn and Wilensky in 1995 defined a general purpose framework for distributed digital library consisting of very high number of digital objects comprising of all type of materials accessible over the network. Kahn and Wilensky defined that the basic entities stored, accessed, disseminated and managed in distributed digital repositories. Introduction of naming conventions for identifying and locating digital objects in digital repository was one of the most important contributions of this framework. In DENST and NCSTRL architecture, basically see the DENST is the server in German. This DENST emerged as one of the first digital library architecture based on three basic principles of a distributed digital library system, so that open architecture, federation and distribution. The developed by Digital Library Research Group at Cornell University, the DENST model was implemented in Network Computer Science Technical Research Library, that is NCSTRL, and available at www.ncstrl.org. This NCSTRL has more than 150 participating institutions and over 2000 digital objects. The DENST architecture specifies 4 core digital library services, that is user interface services, repository services, index services and collection services. The document model of DENST architecture facilitates 3 important functionalities that are considered important to any digital library design. These functionalities are unique document names, a location independent unique identifier called doc ID, multiple document formats such as ASCII, PS and TIFF, document decomposition, that is physical and logical decomposition of a document, interoperability among DENST server. Interoperability among DENST server provides the user with a single logical document collection, even though the actual collection might be distributed across multiple servers. This is accomplished by interaction between a set of DENST server at 3 functional levels, that is server registration. This is being used for locating and indexing the repository site for specific publisher identified through doc ID, distributed searching and distributed document access. The NCSTRL has now moved from DENST architecture and OAI based architecture using ePrints or digital library software and is powered by ARC for harvesting metadata. CRADDL has been developed by Digital Library Research Group at Cornell University. It's known as the Cornell Reference Architecture for Distributed Digital Libraries, that is CRADDL. It is a component or a service based digital library architecture. The CRADDL offers following 5 basic services, that is repository service, naming service, index service, collection service and user interface service gateways. You can see the schematic representation of CRADDL architecture, which defines a basic set of digital library services, and the interactions are shown on your screen. The browser sends the search request to the user interface queries to the index servers and receive the list of hits. Once the list of hits has been passed on to browser, the browser sends document request. The user interface gets the dissemination information from corresponding repository and gives this dissemination to the browser. So, basically the object has been represented to user, and you already know the functionalities of these various services, that is collection service and naming service, because we have seen in this module earlier. FDPS architecture and NSDL. The NSDL and NDLTD are examples of digital libraries based on loosely coupled federated database system, that is FDBS, that are cooperating but are autonomous database systems. Individual participants in FDBS continue their local operation as defined by their own database management system. The FDBMS is the middleware software that controls and coordinates how the component database cooperate. The National Science Digital Library (NSDL) is basically a program funded by United States National Science Foundation, that is NSF, and this has been done by undergraduate division of NSF. Basically, this NSDL consists of the academic material in mathematics, science and engineering discipline. The key objective of NSDL is to produce a view of single coherent library to its user. It's not that collection of irrelated or non-interrelated material. Basically, it produces a single view to the users of the content which has been organized according to various scientific principle. In fact, NSDL does 3 kind of agreements with its participants, that is technical agreement, content agreement as well as the inter-organizational agreement. Under technical agreement, the formats, standards and protocols, access mechanism etc. are decided. In content agreement, the format of content, what will go and what will not go, what needs to be submitted and in which format it needs to be submitted is getting decided, whereas the inter-organizational agreements takes care of the accessibility, what should be made accessible, what are the services, which will be the paid services etc. are decided. Basically, the NSDL design attempts to achieve interoperability at the following 3 levels, that is federation, harvesting and gathering. The federation requires division of responsibility amongst participating members. The participants agree to follow set of standards, protocol and technologies. The process ensures interoperability, but participants are constrained to use agreed set of standard technologies and tools. In harvesting, participants agree to enable some basic shared devices without being required to adopt a complete set of agreement as in the federation. Whereas in gathering, which uses web search engines approach. In this approach, even if participants do not cooperate in any form or manner, a base level of interoperability can be achieved by gathering openly accessible information using a web crawler. Metadata from all the collection is stored in repository and made available to provide NSDL service. The NDLTD is another example of digital libraries based on loosely coupled federated database system, that is FDBS. The Network Digital Library of Thesis and Dissertation, that is NDLTD, the Digital Library of Thesis and Dissertation of master and doctoral students from various universities in US and around the globe, has adopted a federated design approach. NDLTD team created an intermediate application that mediates search requests and has access to descriptions of the search engine's user interface, the type of queries supported and the operators that define and qualify those queries. The NDLTD has also defined the searchable database markup language, that is SearchDBML, an application of extensible markup language, that is XML, for describing each site. The federated search system distributes a query to multiple sites and then gathers the result page into a cache for browsing. The results are displayed for users without merging. The NDLTD has developed a new metadata standard called ETD-MS, that is Electronic Thesis and Dissertation Metadata Standard. This standard is based on Dublin Core. Well, let's talk about CORBA. CORBA is basically Common Object Request Broker Architecture. This Common Object Request Broker Architecture is quite popular architecture in distributed object oriented computing. And the beauty of CORBA is like it can integrate between a number of various servers as or say number of various services which are running on different architecture as well as different protocol. But once you implement the CORBA, what it does is like all services are getting well defined and the inter-service communication takes place using a well defined definition language. There are three key components of CORBA. The first one is the object IDs. The second one is IDL, that is interface definition language, and the third one is IR, that is interface repository. In interface repository, all the object definition, all the service definitions are being stored along with their object IDs. So basically what it tries to do is like it can be considered as a directory wherein all different services which are being provided by different server is listed along with object ID, and a unique object ID is given to the each service, and basically this is being stored using IDL, that is interface definition language. So when there is a computer to computer communication, everyone knows the IDL, and this basically creates a transparency. Like I don't need to know like how to access this service. Normally what once say suppose I want to access some service, what I need to do is go to interface repository, wherein I will have listing of all the service which are provided by different server. Using IDL I can access those service and then my job is done. So in short, Corba is very open and very popular architecture. Corba supports request for services when the client knows specific object to be retrieved as defined by IDL. This is known as static invocation of interface, and when the client doesn't know about object IDs and wants to discover it, this is known as dynamic invocation interface. A proxy process handles all the requests, either static or dynamic. The proxy process interfaces with Corba infrastructure through the object request broker and handles the request on behalf of the client. The ORB is a middleware that connects the client and servers and allows for object communication. The ORB indicates the target objects residing on different server and routes requests to them through message passing. Software Agents Architecture and UMDL. The University of Michigan Digital Library Project, that is UMDL, uses a proprietary architecture to support the federation of loosely coupled digital library collections and services. The core of architecture is the concept of software agent that is based on object technology. An agent is highly encapsulated dynamic module of software representing an element of collection or services with very specific capabilities. The software agents are classified into following three groups, that is user interface agent, collection interface agent and mediation agent. User interface agent, that is UIA, mediates user access to the system. Normally UIAs convert queries and other user interaction into a form that can be understood by other agents. UIAs create and maintain users' profile that other agents can use to support searching. User profiles are consulted by the agents to facilitate delivery of STI services. The collection interface agents mediates access to the collection, that is full text documents, websites or other multimedia objects. The major role of CIA is to provide the registry with information regarding collections. They provide detailed description of content and structure of each collection. The CIAs describe the indexing system associated with each collection and how to search them depending upon the syntax used. CIAs also describe how to access the collection and what protocols to be used for accessing collection. Mediation agent. These MAs manage all the necessary tasks that support the system, such as those tasks that eventually directs a user to collection based on specific query or user profile. Mediation agents communicate only with other agents. The type of mediation agents includes registry agents to manage registry and remora agents that provides STI services. The types of mediation agents include registry agents to manage the registry and remote agents that provides STI services. Mediation agent can also assign with the task of maintaining statistics of various activities. Task planner agent in MA is responsible for managing tasks and other agents. Software agents communicate with each other using a proprietary language developed by UMDL called Conceptus language. Open Archival Information System, that is OAIS. This reference model was developed by Consultative Committee for Space Data System, that is CCSDS, targeted to digital preservation projects. It is a framework for understanding and applying concepts needed for long-term digital information preservation. The reference model does not specify an implementation and is therefore neutral on digital object types or technological issues. The model can be applied at a broad level to archive digital image files, bond digital objects, or even physical objects. OSs have now been adopted as an ISO standard, that is precisely ISO 14721:2003. The OSs framework enjoys the status of de facto standard in digital preservation. OSs reference model provides a high-level overview of types of information needed to support digital preservation that can broadly be grouped into two major umbrella terms called 1. Preservation description information, that is PDI, and 2. Representation and descriptive information. The preservation description information consists of four major types of metadata element, namely reference information, provenance information, context information, and fixity information as mentioned below. Reference information enumerates and describes the identifier assigned to content information such that it can be referred to unambiguously both internally and externally to the archive, for example ISBN and URN. Provenance information documents the history of content information, for example its origin, chain of custody, preservation actions and effect, and helps to support claims of authenticity and integrity. Context information. Context information documents the relationship of content information to its environment. For example, why it was created, relationship to other content information. Fixity information documents authentication mechanism. Fixity information documents authentication mechanisms used to ensure that the content information has not been altered in an undocumented manner, for example checksum and digital signature. Representation and descriptive information. Representation information facilitates proper rendering, understanding and interpretation of digital objects content. At the most fundamental level, representation information imparts meaning to an object's bitstream. For example, it may indicate that a sequence of bits represents text encoded as ASCII characters, and furthermore the text is in French. The depth of representation information required depends on the designated community for whom the content is intended. Descriptive formation metadata contains more ephemeral metadata, the information used to aid searching, ordering and retrieval of the objects. On your screen you can see the interaction between various components of OSS model. Now let's talk about interoperability in digital library. Interoperability is a critical problem in network environment with increase in number of diverse computer system, software application, file format, information resources and users. Digital conversion activities are distributed amongst libraries that hold traditional print-based resources and digitize information to be made accessible universally. Collaboration amongst participants is therefore necessary in order to adopt a framework for achieving suitable level of information sharing. Interoperability is ability of digital library component and its services to be functionally and logically interchangeable by virtue of their having been implemented in accordance with set of well-defined publicly known interfaces. In this model, various services and components can communicate with each other through open interface and clients can interact with them in an equivalent manner. The ultimate goal of interoperability is to create and develop components of digital library independently, yet to be able to call on another efficiently and conveniently. Interoperability in digital library implementation addresses the challenge of creating a general framework for information access and integration across many domains. There are several approaches to achieve interoperability in digital library implementation. Following approaches can be considered to achieve interoperability. The first one is standardization. Standardization is a proven approach to achieve interoperability. MARC and its different variants and Dublin Core are known standards for bibliographic description of records. Z39.50 is known standard for information retrieval. The family of standard approach offers the choice of implementing one or more of several standards. The International Standard Organization, the ISO standard for open system interconnection, created an interoperability framework based on families of standard approach. OSI in its 7-layer structure provides a family of standards concerned with a given set of interoperability issues in area of interconnection. TCP/IP is an OSI protocol. Specification based interaction. Interoperability can also be achieved by describing the semantic and structure of all data and operation. The specification based interaction circumvent the requirement of mediation systems. Some of well-developed enabling technologies to achieve this goal include Agent Communication Language, that is ACL. Mediation. The interoperability can also be achieved by deploying mediation machinery and interfaces for the translation of data formats and interaction modes between components. In the area of interconnection of diverse network gateways play the role of mediation. Mediation interfaces can be designed to augment functionalities and services that may search two digital libraries and present the result with its own value addition. Such mediation facilities are called wrappers or proxies. Mediation technology thrives on standardization. For example, a single mediation system can cover all Z39.50 compliance resources at once. Mobile functionality. Mobile functionalities consist of software agents that travel over the network to the sites where they access the services that they need. The software agents reach back to their original site with results of their works. Java applets and servlets facilitate such mobile functionalities that deliver new capabilities to the client components at runtime. Instead of depending upon standardization or third-party mediation, mobile functionality accomplishes interoperability by exchanging the code that facilitates communication amongst the components. Friends, throughout the chapter, we have seen that this digital library is built around the present internet technologies as well as web technology, and it follows the client server architecture as the internet technology or web technology follows. Moreover, when we design a digital library, we need to take care that it adheres to the key principles like interoperability, modularity, scalability as well as accessibility. Moreover, the major problem in implementing digital library is the diversification of the resources, like you will have number of computer formats you need to handle with. you will have number of bibliographical standards that you need to handle. You will have different operating system, you will have different database structures, and the advancement in web technology, because the presently the only delivery medium of digital library or say client interface for digital library is the web, and the benefits which are available to the web, those are internet standard as well as network standard, as well as the interconnection between various components and servers, that is uh, basically have been developed using open standard, plays a key role while building up the digital library. So, while building digital library, one need to take care of all these aspects, all the open standards or the prevailing standards, to achieve the scalability, interoperability, modularity as well as accessibility. Thank you.